So what we're going to do is we're going to talk about one particular questions of this one. So let's just say if I have a secant of x plus y is equal to x, and we say, hey, let's take derivative implicit, using implicit, there's no way I can solve for y in this case. I mean, can I? Yeah, you can, but it's going to be more ugly. So just take a derivative as s. So how do I take a derivative of this one? Chain rule. Okay, let's do that. That's d to the dx here. What's derivative of secant of x plus y? Secant of x. Hold on, let me change the question a little bit. I don't like secant. That's too much trouble. Let's do cotan. Okay, let's do cotan. Sorry. If I take a derivative of cotangent of x plus y, then I'm gonna get what? Secant x plus y squared, right? What else? No. What is it? Can you say that again?
It should just be dy dx.
No.
No.
Yeah, 1 plus dy dx. There was a chain rule, right?
Yeah, I thought
Can you just say y prime in these cases to make it easier on yourself?
You can if you want.
Okay.
I usually write down implicit, so I usually just do that. So it's up to you. I mean, not some people are more. This is equal to 1 if I take a derivative of 1. Up, so this would dy dx. Okay, so then I would distribute this, so it'd be negative csc squared x plus y, right? Plus dy dx of, this one's going to be negative, sorry. CSC squared of x plus y is equal to 1. Then I just move over. So minus dy dx equal to CSC squared of x plus y is equal to 1 plus CSC squared of x plus y. Does that make sense? And then I just divide it over. So dy dx is equal to negative, I'm just going to do 1 plus CSC square of x plus y over negative CSC square of x plus y. Now, by the way, they cannot cancel out. Okay, please don't cancel. I know you have that tendency, Jonathan. You have the tendency of canceling things out. You cannot cancel out here. Because you cannot cancel out 2 plus 3 over 3. You cannot cancel out 3 become 2. It's going to be 5 over 3. So those are the harder one, and sometimes the harder one could be like involved with the e to the x as well. But since we didn't take a derivative, we don't know how to take a derivative of e to the x, or at least some students don't know how to take a derivative of e to the x, so it can be involved with those as well.
Did you just distribute up there?
Distribute where?
The purple to the red?
Yeah, I just distribute that.
Okay.
Because they are this whole thing is a quantity, I can distribute to this. And then I'll just solve it from there. So this will be a harder one. And sometimes a harder one could be like something like this. I think also on the homework questions. But just talk about this. How do I take a derivative of this one? This, if I just want to take a derivative of this. So you're going to say d to the dx to the xy to the 1 half. Yeah, so you're going to do 1 half, right? Xy to the negative 1 half, and then do a product rule from here. So it'd be y plus x dy dx. This is a result. This is a result. If you just take that 1 half, Yeah, 1/2 xy to the negative 1/2 times y plus x dy dx, and that's it. Okay, so that is the sum situation. Now you can take a second derivative on implicit derivative. Did Mr. Craig talk about that before, or no?
Yeah, don't you have to plug in the y values to like the original thing?
Yeah. Okay, so we're gonna do one. I'm gonna show you how to do one. So you can take a second derivative. So we're gonna use a circle equation. So x squared plus y squared is equal to 25. And not only that, you can use the first original equation as well. So let's just say, in this case, I want to find second derivative. Now notation is going to look like this, d2y dx2. So that will be the notation for second derivative for implicit. So this is an implicit of second derivative. So first of all, let's take the first derivative. 2x plus 2y dy dx is equal to 0. Does that make sense? Very easy. Dy dx is equal to what? Negative 2x over 2y, right? So dy dx is equal to negative x over y. Are we okay here? Now, I have to take second derivative. So I'm going to do a second derivative here. Let's say d to the dx here. And on this side, I'm going to get d2y dx2, like this. So what I do here,
Would you bring the y up, so negative?
low,
Oh, you didn't do quotient rule?
right, low,
D high,
d high, minus
high,
high,
D low.
d low, over low, low. But do we know what dy dx is? So we can say that that's gonna be dy dx, right? So it's just right. Oops, my bad. That's gonna be dy dx here, and dy dx is here. Does that make sense? So it's equal to negative y plus x. Dy dx is what? Negative x over y, right? Over y squared. Am I going too fast?
No. Why couldn't you just do negative x times y to the negative 1?
Yeah, you can, but I don't. I mean, you know, there's a reason why I want to do it this way. So let's just say negative y minus x, right? Square over y, right? So I need a common denominator, so I'm gonna multiply by this by y over y and over y squared. Does that make sense? I multiply this by 1. I need a common denominator.
I hadn't seen the y squared at the bottom, and I was confused for a second. But I'm not.
Okay, so that's equal to y to the negative y squared plus x squared or minus x squared. And I'm going to divide it by y squared, so what am I going to get?
Cube.
So 1 over y squared, right? So it'll be y to the cube.
Why did you multiply by 1 over y squared? You changed what?
Yeah.
Oh,
And I'll take out a negative sign. Now I'm going to write this in different color.
wait, what do we keep changing? I thought you got rid of the denominator. Or you got rid of one of the y's. We got the common denominator of y, and it's y over. Oh, we factored. You took out the y. It was y cubed. Okay, never mind.
And then what do?
You plug in back from the original equation because you know that x squared and y squared equals 0.
Yep. So it'll be minus 25 over y to the third. It's a very, very nice. It's actually, you can actually go back to do that. What time we get off? 10:06.
10 minutes.
10 minutes. So there was a couple things I want you to think about. If ever I want to find horizontal tangent on implicit derivative, then this the things that you should know about, which is horizontal tangent in implicit. So think about inside the implicit. After you take it implicit differentiation, so after implicit derivative differentiation, you usually gonna get dy dx over is equal to some type of fractions, right? So if you set top equal to 0, so if it's top equal to 0, is where the horizontal tangent occur. If you set a bottom equal to 0, which is dy dx is undefined. If bottom equal to 0 is where the vertical tangent occur. Does that make sense? Because if bottom equal to 0, then it's going to be undefined. If it's undefined, it's a vertical tangent. So those are the things that I will say, for us conceptually, you need to understand, because some homework question is going to be involved with that. Is that okay?
Could you zoom in on that box, please? Quite so.
Okay. So you look at this is top, this is bottom, right? Well, if a top equal to 0, that means dy dx equal to 0. That means horizontal tangent. If bottom equal to 0, dy dx is undefined. If it's undefined, that means a vertical tangent. And pretty much that this gonna help you with some homework questions, and then you are pretty much done with that, this section. And we finish all the derivative tomorrow. So pretty much tomorrow you're gonna spend whole day to talk about what's misunderstanding on derivative. On Monday we're gonna have a test of all the derivative all the way to the implicit differentiation.
So we'll have it.
And then Tuesday is gonna be related rate. Woohoo!
No.
Aw,
Wait, Tuesday's gonna be what? Related rates.
Oh, means what?
What?
We're gonna talk about the shadow problem.
Related rate?
That's the worst thing in calculus by
I
far.
just
Yeah.
That's the best thing.
Related rates
That's the
was-
only thing that matter, actually.
Related rates was the one thing last year I was just like, I'll take the L on this.
No, do not take it out. We're gonna go through them. It's actually very, very interesting. Like related rate, like you have to talk about, if I drop a ball in the ceiling, and how fast the shadow is moving. It's not how fast the ball is moving. It's how fast the shadow is moving. And it's actually really, really interesting. If you're walking away from the lamp, how fast the shadow is moving, and how fast the shadow is growing. I don't know if Mr. Craig talked about that.
Yeah.
Yeah?
We use that like very
Huh?
specific.
Yes.
For the teacher I had, he gave us like a list of rules for for related rates, and the first 3 rules were read the problem, and the second rule was be confused, and the third rule was read it again.
No, it's not that bad. I think for me, like when I would come here when I was 15, and the word problem is always my biggest problem. I kind of had to guess what it meant, right? Because you don't know what a decreasing mean. You're like, okay, D is probably negative, and you go from there. And that's even harder for a foreigner, like for people who just come in from a different country. Now, to be granted, it's just as hard for American or foreigner. So, in the term of word problem, everybody in the world hates it. But when it comes down to bottom line, the real world problem in the future, that is going to be dealing with related rate a lot more. Also, another one is also optimization. If you guys think about optimization, it was second set of word problem last year. It's the first one is like find out, what's the biggest triangle you can fit inside a circle. And those are questions that really talk about application purpose in the real world. Like, for example, just look at the iPhone cases, right? iPhone cases, why is that size? They could have been thinner if you think about it, right?
Yeah.
And, just a way that they can stack inside a 20-foot container is probably, they optimize everything. If you look at iPhone, they optimize all the materials, they optimize all the things, even to go down to shipping. It closest to shipping containers, You know, that's exactly one container, exactly how many iPhone they can fit, because every case is exactly the same. They don't have leftover spaces also. Like they will fill up the whole container just like exactly. Like they don't have no waste space. So even the shipping cost is down to the pennies. So they really optimize everything. So it's really, really cool. So we're gonna talk about shadow problem. We're gonna talk about a lot of things. So that's next Tuesday. But Monday is gonna just pretty much the whole test. This is a good review. So I'll give you more review today. This last 3 days homework is all pretty much review. Today we're just gonna talk about a little bit more about implicit derivative, like even with secant and horizontal tangent and vertical tangent. That's it. Okay, then we finish 2.5, and then we're gonna go to 2.6 related rate, and then we finish chapter 2. We're gonna chapter 3. Chapter 3 should be a lot faster.
Chapter 3.
Increasing, decreasing, concave up, concave down.
Oh, okay.
What?
For this example, for the cotangent,
That's it. What's happened?
we found the derivative of cotangent, which is,
Cosecant square. It's one of the formula I gave it to you yesterday.
it's negative cosine.
Yeah, negative cosecant. Anything derivative of c is gonna be automatic negative. It's cosine, cotangent, and cosecant.
No, but then what's after that?
So I distribute this whole quantity inside. So I distributed, so this cosecant square of x plus y distributed 1. Cosecant of square x plus 1 distributed dy dx.
Where'd you get the one?
1 is because derivative of the inside. So,
you found
so,
the derivative?
yeah, find the derivative of the outside, which is cotangent is cosecant square of x plus y, and derivative of inside is going to be 1 plus dy dx.
What? Oh, you found the derivative of x, which is one. Wait, so you found the derivative of the first times the second?
Yeah, so it's x plus y. So derivative of x is going to be 1, derivative of y is going to be dy dx.
Wait, so it's derivative of this.
Yeah, derivative of the outer function, which is cotan, which is cosecant square of x plus y, right? And then take a derivative of the inside of x plus y, which is 1 plus dy dx.
Oh,
Okay, good.
oh yeah, I'm first.
Connor, are you gonna absent a lot more, or is everything's getting better?
Better. Should be 0, 1.
Let's hope so. Don't say that. Yeah, that's a hard promise right there.
Should be 0. Like, there's no reason why it should be 1 for the foreseeable future.
Long as you're taking care of your personal issues, fine. But again, you understand the material, so it's not that bad. Like you understand the stuff, so it's not like I'm worried about it.
I just need to do the homework from last night. That's it.
Yep, go back and redo it. I'll open up for you, but this will be the last time, okay? For those of you guys didn't do it, make sure you go back because the test is gonna be just like this. Test is just gonna be like this. Any homework question is all test question. I can just put a test question just from homework. You know, a lot of those questions are much harder than, and if you know, like the question I asked is probably harder than a AP exam. So that's why usually my student does well is because I give them harder so they can get adjusted. And don't cause my other student late, somebody. Okay, first of all, he's always late.
Yeah, that's what he said. He's on our way here. He was like, Mr. Yale's gonna get on my case again or something. Like,
Yeah. What's up, Connor? Everything okay?
It's just been a lot of shitty things in rapid succession. Family.
What happened?
friends.
You got suspended the other day. You got in a fight?
But yeah, it was out of character for me.
Oh, okay.
This kid disrespected me and he pissed me off and then he tried to taunt me. So
You knock him out. Did you win at least?
no, I wasn't dumb enough to try to actually like knock him out at school. I just kind of gave him a little tap.
That's it?
It wasn't even that big of a deal. So, but he's a little bitch about it. So.
Okay. All right.
But then I got into a car accident the other day.
Oh, everything okay?
Yeah, and I'm just feeling all this, it's just a lot of stuff all in a row, and I'm trying to get back on course, cause I got stuff to maintain, I have a 5.1 GPA, like I'm trying to, and I don't wanna burn out.
Yeah. All right, just take care of yourself, whatever it is.
I'm really trying, and no, you are absolutely right, there won't be, or there shouldn't be any more reason for me not to be.
Okay, I'm gonna open for the last time,
Yeah.
and just because I'm gonna take your word for it, but just go back and make it up, and I know you should do fine on the test,
Yeah,
and I just need a homework credit in there, okay?
you will get it tonight, thank you very much.
All right, no problem.